So I have actually already done a video on Hooke's law, but I've decided that I'm going to delete that and I'm going to re-upload it, this time with a voiceover. It was one of my first videos that I did, and I didn't actually put a voiceover on it. I just put captions on the screen. So we're going to do a voiceover this time. Now the practical itself is really, really simple. It's really basic practical. All I'm going to do is just extend a spring using some force. Okay. Now the force that I'm using is going to be provided by the weight of the slotted masses that I'm going to be hanging from the spring, and then I'm going to add more and more weight, more and more force, and I'm going to watch the spring get longer and longer and longer, and then I can use that to calculate an extension. So firstly, how do we calculate weight? Well, you know from a previous video that weight is equal to mass times gravitational field strength. All I need to do then is take the mass of those slotted masses and multiply it by the gravitational field strength here on Earth, which is about 9.8 newtons per kilogram. I'm going to round it to 10 for this practical, just to make it a bit more simple. So that leaves us with a force of 1 newton per slotted mass. Each slotted mass has a mass of 100 grams. So 100 grams, or 0.1 kilograms, times by 10 gives you 1. So each one of them has a weight of 1 newton. So that's where our force is coming from. Now the position is just where that little pointer is going to be pointing to on the meter ruler that I've got there. So the position at 0 is going to be just 34. Okay, so that's with no mass hanging off it at all, no force applied, no weight. I get a position of 34 newtons. That's its position at no force. Okay. Now you'll see as I add successive slotted masses, the spring should get longer. Yeah, as you'd expect, right? More force, the spring will get longer, and that's what we're investigating today. We're just watching as it gets longer and longer, and as I take successive position readings on the ruler. Now, eventually, I'm going to get to calculate the extension. Okay. So the extension column on the table is given by, well, the definition of extension is how much longer has it got? How much longer has that thing got? Okay, so it makes sense then that at 0 newtons, the spring hasn't got any longer. It's not stretched, has it? So the extension is going to be 0. Yeah. At 1 newton, it moved from a position of 34 to a position 36, so it's extended by 2 centimeters. So my extension is 2 centimeters. Yeah, and it just keeps going on and on like that. Okay, so it just keeps getting longer and longer. The extension keeps getting bigger and bigger. And remember, the extension is always calculated from the force 0, so where it was originally, right at the beginning of the experiment. Okay, I will talk a little bit more about extension in the follow-up video. I will do a follow-up video for this, just having a look at the graph that it plots, and then certain things that we can get from the graph. We can calculate certain things from the graph. Okay, so I'm just going to let this play, and I'll see you in the follow-up video, where we will analyze the data, and we will talk a little bit more about some of the key terms we've used, such as extension in this practical. I will see you then.